What if the force holding you to this planet right now is not a force at all, and everything physics taught you about gravity is only half the story? What if mass does not pull space but bends it, warps the actual fabric of time itself, so completely, so mathematically perfectly, that every object in the universe, from a falling apple to a colliding galaxy, is simply following the curves? What if two black holes crashed together a billion light years away, sent a ripple through the skin of reality? That ripple traveled for a billion years across the entire universe, and we, tiny, fragile, curious human beings on a small rock, built a machine sensitive enough to feel that ripple arrive. We did. That happened 9 years ago. And what if the deepest truth, the reason mass creates gravity at all, connects to an invisible field filling every centimeter of space, a field that gives matter its very identity, without which there would be no mass, no gravity, no stars, no planets, no you? Stay with me, because what you are about to understand will not just change how you see gravity, it will change how you see reality, existence, and your own place inside a universe that is far stranger, far more beautiful, and far more alive than you were ever told. What if gravity is lying to you? Not the numbers, not the equations, not the prediction that if you drop something, it falls. Those are all correct. Breathtakingly, precisely, magnificently correct. What is lying to you is the story you were told as a child, the simple, comfortable story that mass attracts mass, that there is an invisible force reaching across space, pulling things together, keeping you on the ground, keeping Earth around the sun. That story is wrong, not approximately wrong, fundamentally, deeply, categorically wrong in its picture of reality. And the real story, the actual scientific story of why mass creates gravity, is so much stranger, so much more beautiful, so much more terrifying than anything you were taught in a classroom, that once you understand it, you will never look at the sky the same way again. Let us start at the very beginning, with a question that sounds simple but has never been fully answered. What is mass? You might say mass is the amount of matter in an object. Fine. But what is matter? You might say matter is made of atoms, and atoms are made of protons, neutrons, and electrons. And protons and neutrons are made of quarks. And what are quarks made of? And here, right here, is where the comfortable ground disappears beneath your feet, because at the deepest level we can currently probe, the elementary particles, the quarks, the electrons, the fundamental building blocks of everything you have ever touched, tasted, or loved, are not tiny balls of stuff. They are excitations in quantum fields. They are ripples in invisible, mathematical, universe-spanning fields that stretch across all of space. And mass, the property that makes matter heavy, that makes gravity happen, is not something these particles inherently own. It is something they acquire through interaction with a field called the Higgs field, a field that fills every single cubic centimeter of the universe, including the empty space between your atoms, including the space between galaxies, including the void that most people call nothing. The Higgs field is not nothing, it is something. And it is everywhere. Particles that interact strongly with the Higgs field drag through it, and that resistance, that reluctance to be accelerated, is what we experience as mass. It is why pushing a bowling ball requires more force than pushing a tennis ball. The bowling ball's particles interact more strongly with this invisible cosmic field, and so they push back harder. Photons, particles of light, do not interact with the Higgs field at all. They slide through it effortlessly, which is why they have no mass, which is why they travel at the speed of light, which is why nothing with mass can ever quite reach that speed. Because the closer you get, the more the Higgs field resists, and the more energy it takes, approaching infinity as you approach light speed. This is not poetry, this is not metaphor. The Higgs boson, the quantum ripple in the Higgs field, was detected in 2012 at the Large Hadron Collider, the most complex machine human beings have ever built, buried 100 meters underground beneath the border of Switzerland and France, using particle beams containing more energy than a speeding freight train, colliding protons together 40 million times per second. We found it. We found the particle that gives particles their mass. And in doing so, we confirmed that mass is not a given. It is earned through interaction with the universe itself. Now. Here is where gravity enters. Once a particle has mass, once it has acquired this property through its relationship with the Higgs field, something remarkable happens. That mass does not just sit there passively. That mass bends spacetime. Spacetime, not space alone, not time alone. Spacetime, the four-dimensional fabric of the universe, 3 dimensions of space woven inseparably with 1 dimension of time, forming a single continuous mathematical structure that is the stage on which all of physics performs. Einstein, and I want you to really hear this, Einstein did not discover that gravity is a force. He discovered that gravity is not a force at all. It is geometry. It is the shape of space-time in the presence of mass. A massive object does not reach across space and pull other objects toward it. A massive object curves the space-time around it, and other objects moving through that curved space-time follow the curves, not because something is tugging them, but because the curves are the straightest paths available through a geometry that is no longer flat. Think about the surface of the Earth. Draw 2 perfectly straight lines starting at the equator, both pointing due north, both perfectly parallel. They will meet at the North Pole. They crossed. They converged. Not because some force pushed them together, but because the surface they were drawn on is curved. The straightest line on a curved surface is not the same as the straightest line on a flat surface. In mathematics, these straightest paths are called geodesics. In our universe, objects follow geodesics through curved 4-dimensional spacetime. That following of geodesics is what we call gravity. The Earth is orbiting the Sun, not because the Sun is pulling it with invisible fingers. The Earth is following a geodesic, the straightest possible path, through spacetime that has been curved by the Sun's enormous mass. Without the Sun's mass to curve that spacetime, Earth would travel in a straight line off into the darkness. It is the curvature that makes the path circular. Remove the mass, remove the curvature, and there is no orbit, no gravity, no solar system. And here is something that should stop your heart for a moment. You are doing this right now. Your body, your mass, however modest, is bending space-time around you. Every atom in your hand is warping the fabric of the universe, right now, as you exist. The effect is too small to measure with any instrument we currently have, but the principle is identical to what the Sun does to the entire solar system. You are shaping space and time by existing within them. You are not a passive passenger in the universe. You are a participant in its geometry. The curvature created by mass is not just philosophical. It is measurable. It is dramatic. It is visible. During the solar eclipse of 1919, astronomers photographed stars near the edge of the Sun and confirmed that their light was bending around the Sun's massive body. Light, which has no mass, which cannot be pulled by any force, was curving. Why? Because it was following a geodesic through spacetime that the Sun had curved. The universe was behaving exactly as Einstein's equations predicted, and the confirmation sent shockwaves through every scientific institution on Earth. But even that is not the most shocking confirmation. In September of 2015, instruments in Louisiana and Washington state detected something that had never been detected in human history. They detected gravitational waves, ripples in the fabric of space-time itself, created by 2 black holes colliding over 1 billion light-years away. These black holes, each dozens of times more massive than the Sun, had been spiraling toward each other for billions of years, and when they finally merged, the collision was so violent, so catastrophically energetic, that the ripples it sent through space-time traveled for 1 billion years across the entire universe and arrived at Earth, where they stretched and squeezed the distance between 2 mirrors by a fraction smaller than 1/10,000th the width of a single proton dot. Think about that measurement. We detected a change in the distance between 2 points that is smaller than 1/10,000th the diameter of a proton, the most sensitive measurement in the entire history of science. And what it confirmed was not just Einstein's prediction. It confirmed that space-time is real, that it can wave, that it can ripple, that it behaves like a physical medium, like an ocean that carries waves when massive objects accelerate through it. Mass and space-time are in constant conversation, and we have now learned to eavesdrop on that conversation. But here is where the story gets uncomfortable, because science that is honest must acknowledge what it does not know. We do not know how to unite gravity with quantum mechanics. General relativity, Einstein's magnificent, geometrically elegant theory of gravity, works perfectly at large scales. We can use it to predict the motion of planets, the bending of light, the behavior of black holes, and the expansion of the universe, and it is always right, always precise, always in perfect agreement with experiment. Quantum mechanics, the theory describing the behavior of particles at atomic and subatomic scales, also works perfectly. It is arguably the most precisely tested theory in the history of science. Its predictions agree with experiments to more than 10 decimal places. 2 perfect theories, both describing the same universe. And when you try to combine them, when you try to write a quantum theory of gravity, the mathematics produces infinities. Nonsense. Predictions of infinite probabilities, infinite energies, quantities that cannot exist in physical reality. The equations break down, the theories are incompatible. And despite decades of brilliant work by thousands of brilliant physicists, this incompatibility has not been resolved. String theory proposes that all fundamental particles are actually tiny, one-dimensional strings vibrating in 10 or 11 dimensions, and that different vibration patterns correspond to different particles. The graviton, the hypothetical quantum particle of gravity, would be a specific vibration mode of these strings. String theory can potentially unify gravity with quantum mechanics, but it predicts phenomena at energy scales we may never be able to reach experimentally, and after 50 years of intense development, it has not made a single confirmed experimental prediction. Loop quantum gravity takes a different approach. It suggests that space-time itself is not continuous, but is made of discrete, finite loops woven together into a spin network, a quantum fabric of space. At the smallest possible scale, the Planck length, approximately 10 to the negative 35 meters, space is granular, not smooth. Gravity at the quantum level would be the behavior of these loops. This theory also remains experimentally unconfirmed. We are, honestly and openly, in a state of profound ignorance about the deepest nature of gravity. We can use it. We can measure it. We can detect its waves crossing the universe. We can photograph black holes, regions where gravity has curved space-time so severely that not even light can escape. We have done all of these things, but we cannot write a complete, consistent, mathematically unified theory that describes gravity at the quantum scale. And that ignorance, that gap, that crack in our understanding, is not a failure of science. It is science's greatest triumph, because science is the only human endeavor honest enough to say clearly, specifically, and publicly, here is the frontier. Here is the edge of what we know. Here is where the known universe ends and the unknown begins. The reason mass creates gravity is that mass interacts with the Higgs field to acquire the property of mass itself, and that mass then tells space-time how to curve, and that curvature tells everything else how to move. Mass and geometry are not separate phenomena. They are a conversation, an ongoing, dynamic, universe-spanning conversation between matter and the fabric of existence, a conversation that has been happening for 13.8 billion years, a conversation that created every galaxy, every star, every planet, every ocean, every creature, and every thought ever thought by any mind anywhere in the cosmos. You are not merely subject to gravity. You are a participant in the process that makes gravity possible. Your mass is warping space-time right now. You are in conversation with the universe, whether you know it or not. And the most honest, most thrilling, most human thing I can tell you is this: we are only beginning to understand what that conversation means. The real science behind why mass creates gravity is not a closed book. It is a book that humanity is still writing, still discovering, still being astonished by with every new page. We have learned that mass is not a birthright of matter, but a property earned through interaction with the Higgs field, a field that permeates all of space and gives particles their gravitational identity. We have learned that gravity itself is not a force, but a geometry, the curvature of four-dimensional space-time caused by the presence of mass. a curvature so real that it bends light, slows time, and sends waves racing across the cosmos at the speed of light. We have learned that our two greatest theories, general relativity and quantum mechanics, despite their individual perfections, remain at war with each other when it comes to gravity's quantum nature, and that resolving this war may require ideas we have not yet imagined. What this entire journey reveals is something profound about both the universe and about us. The universe is under no obligation to be simple, comfortable, or intuitive, and yet it is so structured, so mathematically consistent, and so astonishingly beautiful that a species of curious pattern-seeking creatures on a small planet was able to reach out with mathematics and touch the geometry of the cosmos itself. Gravity is not just a force that keeps your feet on the ground. It is evidence that matter, space, time, and reality itself are woven together in a tapestry of breathtaking elegance. And we, small as we are, curious as we are, have learned to read the pattern. An ongoing, dynamic, universe-spanning conversation between matter and the fabric of existence, a conversation that has been happening for 13.8 billion years, a conversation that created every galaxy, every star, every planet, every ocean, every creature, and every thought ever thought by any mind anywhere in the cosmos. You are not merely subject to gravity, you are a participant in the process that makes gravity possible. Your mass is warping space-time right now. You are in conversation with the universe, whether you know it or not. And the most honest, most thrilling, most human thing I can tell you is this: we are only beginning to understand what that conversation means. The real science behind why mass creates gravity is not a closed book. It is a book that humanity is still writing, still discovering, still being astonished by with every new page.